Ladies and gentlemen, I'd planned to speak to you tonight to report on the State of the Union. But the events of earlier today have led me to change those plans. Today is a day for mourning and remembering. Nancy and I are pained to the core by the tragedy of the Shuttle Challenger. We know we share this pain with all of the people of our country. This is truly a national loss.
January 28th, 1986. This date represents one of the most dark events in space exploration history, the Space Shuttle Challenger disaster, which caused the death of 7 astronauts just after 73 seconds from the liftoff. The mission was named STS-51L, and it marked the 10th flight of the Challenger. The commander of the crew was Dick Scobee, a former combat aviator in the Vietnam War, who then started his career as an astronaut. He flew to space 2 times, both aboard of the Challenger. Michael Smith was the pilot, but before starting his career as an astronaut, he was an aircraft pilot with thousands of hours of flying time. This mission was his first one. There were 3 mission specialists: Ellison Onizuka, a flight test engineer from Hawaii, who at the time of the mission had already successfully flown into space with the Discovery Shuttle; Judith Resnik, electrical engineer, pilot and the 4th woman to ever fly to space; Ronald McNair, an astronaut and physicist who had already been a mission specialist on the STS-41B mission. And finally, the payload specialists were Gregory Jarvis, engineer and astronaut assigned to conduct research in his first flight, and Christa McAuliffe, a teacher part of the Teacher in Space project, who would have come back to classroom after the spaceflight. But before diving into the disaster itself, you need to have some details about the background of the mission. Firstly, what exactly is a space shuttle? The Space Shuttle was a partially reusable low Earth orbit spacecraft system produced by Morton Thiokol and used by NASA to conduct in-orbit research and the deployment of commercial, scientific and military payloads. At launch, it consisted of the orbiter, which carried crew and payloads, the external tank, which contained the liquid hydrogen fuel and the oxidizer, and 2 solid rocket boosters, the first solid propellant rocket ever used in human spaceflight. NASA built 5 orbiters, and the Challenger was the second. The SRBs provided most of the thrust and liftoff, built in 4 sections with 3 joints sealed by 2 critical O-rings. Rated critically 1R, these O-rings were essential to prevent high-pressure gas leaks that could endanger the crew. In the 1970s, testing showed joint rotation could weaken seals, and by 1981, the first signs of O-ring erosions appeared. Issues continued, with soot between O-rings in 1984 and a cold plunge in 1985 revealing that low temperatures impaired the O-rings' flexibility, letting hot gases pass through. To correct these issues, engineers proposed a redesigned field joint with a metal lip to limit the movement and a spacer to provide more thermal protection. However, even though Morton Thiokol started to produce redesigned, safer cases, they used already manufactured casings for the upcoming launches because the redesigned ones would not have been available until the next year. Maybe if they hadn't been so hurried and prioritized safety measures, what we know is going to happen wouldn't have happened. Hence, here we are on the disastrous mission. The mission should have been launched in July 1985, but it was delayed to January 1986. If only they knew what was going to happen. Here we are again on that day, 28th January 1986. That day the air temperature was lower than the lowest one on which engineers conducted the tests. There was concern about the launch since it was feared that the O-rings would not be extruded to form a seal at the time of launch because of the cold temperatures. However, after a private discussion, Morton Thiokol's leadership changed their opinion and stated that the evidence presented on the failure of the O-rings was inconclusive and that there was a substantial margin in the event of a failure of erosion. Therefore, it was decided, unfortunately, to proceed with the launch. But there was another problem. The cold temperatures not only caused issues to the integrity of the O-rings, but they also caused ice to form on the fixed surface structure. This could look like a marginal risk, but actually it was concerning. When the rocket lifted off, the ice would be violently thrown during launch, it could potentially damage the orbiter's thermometer protection system. Even though concerns were also raised on this issue, the only thing they did was delay the departure for an hour to allow more ice to melt. At 11:38 a.m. or T+0, Challenger lifted off from the Kennedy Space Center Launch Complex 39B. But soon after the ignition, beginning at T+0.678 until T+3.375, 9 puffs of dark gray smoke were recorded escaping from the right-hand SRB, near the place that attached the booster to the external tank, all caused by joint rotation in the field joint of the right-hand SRB. Additionally, the cold temperatures, as it was proved, prevented the O-rings from creating a seal. Even worse, while the rocket was waiting to be launched on the launch pad, rainfall had likely accumulated within the field joint, further compromising its sealing capabilities. As a result, hot gases were able to travel past the O-rings and erode them. At T+58.788, it was captured the beginnings of a plume near the aft attached strut on the right SRB, right before passing through the maximum dynamic pressure, the most stressful part of a rocket launch, for the rocket itself. After just 1 second, the plume became more defined, and the enlarging hole caused a drop in internal pressure. Consequently, a leak had begun in the liquid hydrogen tank of the ET, and the Space Shuttle's main engines pivoted to compensate for the booster burn-through, which was creating an unexpected thrust on the vehicle. At T+66.784, the pressure in the ET began to drop, indicating that the flame had burned from the SRB into the tank. However, the crew seemed not to be aware of the vehicle and flight anomalies. At T+68, the Capcom, the flight controllers, told the crew, "Challenger, go at throttle up," indicated that the main engines had throttled up to 104% thrust. Scobee, answering the message, said, "Roger, go at throttle up." This was the last communication the crew had with the ground. Arrived at T+72.284, the right SRB pulled away from the aft strut that attached it to the ET, causing lateral acceleration that was felt by the crew, while there was a pressure dropping in the tank. The pilot at that moment said, "Oh." This was the last crew comment recorded. Then, the unthinkable happened. At T+73.124, white vapor was seen flowing away from the ET, and the aft dome of the tank fell off. All liquid hydrogen in the tank was released, and this pushed the tank forward into the liquid oxygen tank with a tremendous strong force, and the SRB collided with the inter-tank structure. These events made the shuttle's deck change abruptly the attitude and direction. The time came. While traveling at supersonic speed, the Challenger encountered aerodynamic forces it was not designed to withstand, and broke into pieces. Initially, NASA was not aware of the explosion, and therefore NASA Public Affairs Officer Steve Nesbitt continued to read out flight information. However, at T+89, when the video of the explosion was seen in mission control, the ground control officer reported negative contact and loss of downlink, because they weren't receiving transmissions from Challenger. Nesbitt stated, "Flight controllers here are looking very carefully at the situation. It was a major malfunction. We have no downlink." Soon afterward, he said, "We have a report that the flight dynamics officer that the vehicle has exploded. The flight director confirms that. We are looking at checking with the recovery forces to see what can be done at this point." At the time the orbiter separated into pieces, the crew cabin traveled in a ballistic arc, reaching 65,000 feet of altitude. Within 2 seconds of the separation, the acceleration had dropped vigorously, and the cabin was in free fall. However, the forces involved at this stage were not sufficient to cause lethal injuries to the crew. We know for sure that at least some of the members were alive and conscious because the personal egress air packs, which provided breathable air for the crew in case of an emergency, were activated for Smith. The location of Smith's activation switch indicated that either Resnik or Onizuka activated it for him, trying to save him. Furthermore, while analyzing the wreckage, it was discovered that several electric system switches on Smith's right-hand panel had been moved from their initial position, and it was stated that neither the explosion nor the subsequent impact with the ocean could have moved them. That could only mean one thing: Smith had moved them, presumably in a futile attempt to restore electrical power to the cockpit after the crew cabin detached from the rest of the orbiter. Even in a catastrophic moment, these astronauts didn't surrender and tried to save the rest of the crew with bravery and determination. The only hypothesis that was made was that the crew members lost consciousness after the orbiter breakup due to in-flight loss of pressure. At this point, you could be wondering, couldn't they have been ejected from the shuttle? Unfortunately, the space shuttle did not allow an escape during powered flight. It was considered during development, but the expected high reliability of the space shuttle caused NASA to conclude that it was not necessary. Right after the disaster, NASA began recovering debris and crew remains. Widely scattered SRB fragments were identified by submarines and submersibles. On March 1st, sonar detected the damaged joint of the right SRB, recovered a month later. Then came the saddest moment. On March 7th, US Air Force divers confirmed the crew compartment debris. Although intact after the explosion, it was severely damaged upon ocean impact. Multiple trips brought the remains to port, where they were taken to Dover Air Force Base, each casket draped with an American flag and escorted by an honor guard, before being returned to the families. On the 28th of January, US President Ronald Reagan had been scheduled to give the 1986 State of the Union address. However, he decided to postpone it and instead address the nation about the Challenger disaster from the Oval Office. On January 31st, the President and First Lady traveled to the Johnson Space Center to speak at a memorial service honoring the crew members. The Air Force band sang God Bless America, while NASA T-38 Talon jets flew directly over the scene in the traditional missing man formation. But how did this tragedy shape future missions? Following the Commission's recommendation, NASA redesigned the SRBs. The new design included a capture feature in the joint to prevent rotation, sealed with an extra O-ring, which reduced potential rotation to 15% of previous levels. Heaters were also added to maintain the O-ring temperature. The redesigned SRB passed tests with intentional flaws and was certified in 1988. NASA updated safety standards across the shuttle program. The main engine's thrust was capped at 104% and the landing gear was enhanced. An escape system was added for emergencies, allowing astronauts to slide down a pole before deploying parachutes, though it wouldn't have saved the Challenger crew. The Teacher in Space program, cancelled in 1990, was replaced by the Educator Astronaut Project in 1998. Barbara Morgan, the backup for McAuliffe, became a mission specialist and flew on STS-118. As for every hero, also the Challenger crew members had their legacy. In the Johnson Space Center, a tree for each astronaut was planted in NASA's Astronaut Memorial Grove. 7 asteroids were named after the crew members. 7 craters on the far side of the moon were named after the astronauts. The landing site of the Opportunity Mars rover was named Challenger Memorial Station. Memorials have been established in several parts of the United States. An American flag, later named the Challenger flag, was carried aboard the Challenger. It was sponsored by Boy Scouts in Colorado after being recovered intact in its plastic container. Moreover, Onizuka had included a soccer ball with his personal effects, and when it was recovered, it was brought to the International Space Station, and today it is on display at Clear Lake High School in Houston, which was attended by Onizuka's children. Even the 1986 motion picture Star Trek IV was dedicated to the crew members, with an opening message that stated, "The cast and crew of Star Trek wish to dedicate this film to the men and women of the spaceship Challenger, whose courageous spirit shall live to the 23rd century and beyond." The Space Shuttle Challenger disaster has been a horrible moment in the history of the space exploration path. But just like every other of these moments, it gave space agencies the means to improve even more the spacecrafts and the organization of the missions and inspired thousands of people. The crew members are legends, and legends never die. However, that was not the last terrible event that occurred with the Space Shuttle. After almost 2 decades, another space shuttle, the Columbia, with its crew, had almost the same fate. Let me know in the comments if you want another video also on the Columbia disaster. And let's remember these heroes forever.